Good day, everyone. We will discuss our topic about statistical and induction learning.
Statistical learning. What is statistical learning? Statistical learning is a field of study that focuses on developing mathematical and computational methods for analyzing complex data sets. It involves the use of statistical techniques and algorithms to extract meaningful patterns and relationships from data. Statistical learning is often used in data mining, machine learning, and artificial intelligence applications. It is involved in identifying the underlying structure and patterns in data and using this knowledge to make prediction or classify new data points. Some examples of statistical learning. First is linear regression. Linear regression is a statistical method used to model the relationship between a dependent variables and one or more independent variables. For example, suppose you want to predict the price of a house based on its square footage. You would use linear regression to create a model that predicts the price of a house based on the square footage of the house. First step. To create the model, you would first collect data on the square footage and price of a sample of houses. You would then use statistical method to fit a line to the data point that best represent the relationship between square footage and the price. The line would then be used to predict the price of a house based on its square footage. The result, once the model has been created, it can be used to predict the price of a new houses based on their square footage. If new data is collected and the model needs to be updated, statistical learning methods can be used to refit the line to the new data and improve the accuracy of the model. This is a powerful approach to machine learning because it allows us to make predictions based on data and continuously improve our models as we collect more data. Second, some example is the decision tree classification. Decision trees are a popular methods in machine learning used for both classification and regression tasks. In decision tree classification, the algorithm creates a tree-like model of decision and their possible consequences based on the input features. For example, suppose you want to classify whether a bank loan application is approved or not based on a factor such as credit score, income, employment status, and loan amount. The algorithm would use statistical method to determine the most important features for making the classification decisions, and then to create a decision tree based on these features. The decision tree would consist of a series of nodes that represent decisions based on the input features, with each node leading to a branch that corresponds to a possible classification outcomes. The algorithm would use statistical method to determine the best split of each node based on maximizing the separation of the classes. Once the decision tree is created, it can be used to predict whether new loan applications will be approved or not based on their input features. The algorithm will follow the decision tree to make the classification decision and output the corresponding classification results.
About induction learning. Inductive learning, also known as inductive reasoning, is a type of machine learning technique where a computer program automatically learns from the examples and generalized patterns and relationships from the data. The goal is to identify patterns in the input data and use those patterns to make predictions about new unseen data. Inductive learning is open to use in supervised learning, where the program is given a set of labeled examples as input, and the task is to learn a function that makes maps in the input to the correct output. The program then applies this function to new unseen data to make. According to Jason Brownlee, in his article, Basic Concepts in Machine Learning, an excellent method to understand how inductive learning works is, for example, if we use given input samples, for example x, and output samples fx, from the perspective of inductive learning, and the problem is to estimate the function of f. These are some practical examples of induction are credit risk assessment. The X is the property of the customer. The Fx is credit approved or not. Disease diagnosis. The X is the characteristics of a given patient. The Fx is the patient disease. Face recognition. The X are bitmaps of the face we want to recognize. The Fx is a name assigned to that face. Automatic steering, autonomous driving. The X is bitmap image from a camera in front of the car. The Fx is the degree to which the steering wheel should be turned.
There are some differences between induction and statistical learning.
The conclusion. In conclusion, induction learning is better suited from machine learning that requires high accuracy and reliability as it involves inferring relationships from given data or procedures, whereas statistical learning is sufficient for making decisions in external data can be obtained. Such distinctions should be kept in mind when selecting the right approach for machine learning.
And that could be all. Thank you.